Hello and welcome back to video 2 of chapter 2. Let's just pick up right where we left off. We were talking about multiples, which are the results of multiplied numbers, and this word that goes in your next blank, we're at the top of page 5 in your notes. The word that goes in the blank is divisible. A number is divisible by another if it can divide evenly without a remainder. So if I divide a couple of numbers and I end up with no remainder, no decimal value, that number is divisible by the other. For example, here's a question. Determine whether 45 is divisible by 9. So if I think to myself 45 divided by 9. Now before I go on, the fraction bar means division. Okay, the fraction is division. So that means 45 divided by 9. It's also a fraction, 45 ninths. But if you see that, you can think it is the math operation, 45 divided by 9. If I do that, 45 divided by 9 is 5. And I notice there is no remainder. So I can say yes, 45 is divisible by 5. Or I'm sorry, by 9. That particular question, because you get 5 without a remainder here. Okay, so that's divisibility, and it's going to be important to us for some tricky things that are coming up here for us. So if I move on to page 6, a couple vocabulary words here on page 6 and 7, and top of page 6, prime numbers. Prime numbers have exactly two factors, one and itself. Okay, for example, right, let's take the number 7. The only way to multiply to get 7 is 1 times 7. There's no other way. You can't do decimals, can't do fractions, can't do negative numbers. Therefore, 7 is prime. That's the only way. There's two factors. Two factors. 1, that's a factor of 7. 7 is a factor of 7. Another prime number, how about 19? Okay, 19 times 1 is 19. Is there another way to get 19 multiplied? No, there's not. It's the only way, therefore it's prime. Okay, so every number, every positive number without a decimal, called positive integers or whole numbers, every positive integer can be classified as either prime or the next blank at the bottom of page 6, it looks like. Any number with more than two factors is called composite. Okay, give me an example. How about 8? 1 times 8 is 8, but I could also do 2 times 4. Okay, so 8 has 4 factors. 1, 2, 4, and 8. These are all factors of 8. There's 4 of them. Therefore, 8 is composite. Okay, so every number can be classified as prime or composite. Okay, the number 1, we don't consider that neither prime nor composite. Okay, the first prime number we really consider is 2. 1 times 2, that's really the first one for us there. Well, then we get to this next thing. Now this is going to be a little wild for you. This is maybe the trickiest thing we've done up to this point, just because it's either been a long time since you've done it, probably, or maybe you've never done it. But it's valuable to us for times in math that come later that might be hard for you to understand, but it is something that's expected for you to be able to do. Every number that exists can be written as a product of primes. Now, before I go on, product means multiply. So what this is saying is if you have any number, you can take a whole bunch of prime numbers and multiply them and end up with that number. Okay, it sounds more confusing than it really is. It's called prime factorization. Prime factorization. Okay, I'm going to show you how to do it on the next slide, and I'll probably just do the first example and then end the video, and then I'll start the second video or the next video with the next two done. This is one that's going to take some time for you. Probably one of the most frequently missed questions on the final exam. It's usually always on there, so it is valuable for us. So if you take a look at this slide right here, which I believe we are on page 8. This is actually 3 different questions. Okay, this is like, here's number 1, number 2, number 3. Like I said, I think I'll just do number 1 here. Maybe 1 and 2. We'll see where the times would go here. But the trick to do prime factorization is you start with the number 72. They're asking you to find the prime factorization of 72. What you ask yourself is you say, well, can I multiply to get 72? Well, you can. You can do 9 times 8. Now remember that the dot means multiply. I'm going to use that to save space. 9 times 8. And then I ask myself, are any of these numbers prime? 9, no. 8, no. Neither of them are prime. So you continue doing the same thing that you just did with the 72. Because remember, you're trying to find prime numbers that multiply. So we're going to basically continue dividing 9 out now. 9 can be 3 times 3. And 8 can be 4 times 2. Okay, now you'll notice in this line you have 3 prime numbers, the 3, the 3, and the 2. So you want to circle them. Circle your primes. Now the reason I like you to circle them is because that's telling you, hey, you found some prime numbers that go into 72. But you notice one of those numbers is not prime, 4. The 4 can be rewritten as 2 times 2. It's not prime up here, but now it is prime. So the prime factorization basically are all the prime numbers multiplied together. So you have 3 2's, 1, 2, 3. So you have 2 times 2 times 2 times, and then you have 2 3's, 3 times 3. So that is the prime factorization of 72. Now if you multiply this up, you can grab your calculator and multiply it. 2 times 2 times 2 times 3 times 3. That all multiplies to get 72. Now there's a better way to write this answer, and I would challenge you to practice this, and you can input your answers in my math lab this way, I believe. Or if you notice, you have 2 times 2 times 2, and we learned about exponents. That's 2 to the power of 3 times 3. There's 2 3's, so that's 3 to the power of 2. That is also equal to 72. So again, it's prime numbers multiplied that end up being that value right there. Okay? So prime factorization, it's going to take you some time probably to practice this, and go over it, and to master this concept. But it is something that is valuable for us later on in math, even though it might not make a lot of sense right now. It is. And I wish you good luck on that. When I start the next video, we will continue with problem number 2. See ya.